All right. Again, thank you to both of you for the presentations. I would like to start by asking, since you both talked about, in different ways, about dynamic modes of production or let's say fabrication, but the idea of, both in terms of materiality, this kind of generative systems in design, which also the session is about. You both talked about including dynamic systems in design or in fabrication processes. So I would like to start by asking, how do you think, or do you think there's a difference between how a structural engineer and an architect approaches the idea of dynamic design or construction or fabrication? Like, how would you kind of communicate the idea between the two professions?
That's the million-dollar question. Honestly, you asked the question of the whole day, because I've been thinking the whole day, where is the difference between engineering and design, let's say? And how would you define design and how would you define engineering? And I think in the morning's panel, more than any other one, I kept asking myself, is this an engineering problem or a design problem? And I don't think there's probably an answer, which if I were you 6 PhD students, I would think about that anyway.
The lines are blurred for sure. I think they're becoming more blurred. And we heard today about tools and how those tools are in fact blurring the lines. And I think that for us in practice, we still have a lot of hurdles when we try to implement some of these ideas, and some of them aren't architecture actually. Some of them are just the practicality of construction, right? So these lofty ideas that we're starting with, we're developing at smaller scale.
Yes.
Smaller scale is really important for us, because I think that at that scale it helps us to understand perhaps what can be done at much greater scales. So I really think that the more actually that the lines can be blurred, I think the more fertile the ground is.
But are you worried, Mark, about your turf?
Not really. This is an interesting thing. I've been thinking about this today as well. With our tools that we have available to us, will we lose track of the fundamentals of how these structures behave, or the fundamentals of architecture that really are so important to a successful project or city? So I think we have to be wary of that, because I think that's very important. I think that the more that we can fill ourselves with an education that sees both, the better. So you can have expertise, but I really believe that the best architecture, and maybe counter to that, the best engineering is one that comes from really a full palette of ideas that are developed during the process that many of you are in right now.
Which to some point I think is what Greg did with the bug problems. I mean, it's like this, you're back and forth, you said, between these people simulating it. At some point I think you said that the patterning was not, the styling was not necessarily the result of optimization. And I'm just curious, at some point, but you said it had consequences. So at what point in time did you find out that it had consequences? Was it through an outside kind of company coming back and telling you that, and then did you have to go back and modify that?
Well, maybe to say a last thing about Leif's question, I think these tools tend to push the questions a little bit towards constraints, towards finding the critical constraints. So if you're using a tool with, a lot of variables, you start to hang a lot of design decisions on the selection of the correct variables, rather than maybe looking for the right grain or character in the design. So I mean, that's just one thing that I've seen today, is that it's a lot of the PhD proposals will succeed or fail as design PhDs on the selection of the appropriate constraints. And that would make me maybe a little nervous. I mean, it definitely puts the heat on, you know, energy, street morphology, whatever it's going to be, rather than saying, I'm looking for a certain urban texture, and this is the range of textures, and I'm going to need the following constraints to generate those textures. Where you're saying, actually, at the outset, I'm looking for something, rather than I'm hanging it on a constraint. So that was just something that I kind of reflected, not on your two, but on all 6 of you, that the tools lead one towards almost an engineering and optimization solution, but an optimization based on a constraint rather than optimization based on a design intent. So, but I think that's because the space between design and engineering is so in the boat, it's totally refreshing, because there's, you know, Hervé Delvaux structures in Paris, and they're doing all the laminate schedules. You know, there's Fred Karugla, who's doing all the dynamics of the boat. There's CFD, and there's me. And everybody's in their own box, and we just all throw things over into the other person's box. And the digital tools are giving us a lot of the feedback to make constructive decisions. But it's not like it's an optimized thing at all. I mean, what I'll say is, you know, I'll say to Fred, give me your surfaces. And he'll be like, oh my God. And then the next day I'll give him his surfaces back, and he'll say, this is gonna be a mess. Then we'll send those into CFD, and all of a sudden they're doing something we didn't expect, or they're providing buoyancy in a certain dynamic that we didn't expect. And Fred will say, you know what, it's wrong, but if you could live with this, suddenly it's right. And then we're finding new things, so.
I think when you're finished with your project, your next project should be the American automobile industry, because everything that you talked about is, no, really, I'm serious. Talk about a design opportunity,
Yeah.
right? But it's about the parameters that he talked about, and a design opportunity that, anyway, so that's just that's a side comment. That really doesn't have anything to do with our engineering and architecture in this context. But anyway, these are great ideas, and sometimes it's intuitive, and sometimes it comes from these more advanced ideas, these more advanced tools that are helping us see it. So I think that's a good example of just, in particular, as you mentioned, the whole design and the idea of pulling that whole out. I mean, it's a really important idea that perhaps people think about in terms of the performance of these vessels, but it comes out in a way that's definable with these types of models.
And one thing I'll say, what's crazy is the level of intuition on all parts. Even all the way to the person doing the CFD will say, I have a feeling this model's not going to resolve even if we give it 9 days. And I think every time the person doing the CFD said our analysis isn't going to converge, he was always right. So, but this one looking at a lot of patterns. I mean, that guy spends his whole time looking at pressure gradients and fluid patterns and stuff, so.
I have a question for you, Greg, in regards to kind of the shift that has happened between, let's say, animate form and where you are now. When animate form was first introduced, there was this idea of biomorphic form, time-based processes, and now it seems that most of your concentration is on fabrication and more kind of material, exploring that aspect of design. And I'm just curious to know if it has anything to do with the type of forms that's being generated based on these type of processes, because now the continuation of that is generative processes, which is kind of not focusing more on, and well, it's continuing the idea of simulating behavior now within objects or a collection and so on, which is perhaps making it even more difficult to materialize. And at some point in time, I think you both touched on, you know, material in the sense of the object, right? And its role in defining it. So I'm just curious, I guess the question is, was that really kind of one of the main drivers in your focus, especially with the last book that came out, was really kind of looking more on composite surfaces and so on.
Well, I think, you know, on reflection, I realized with the tools that I was using in the 90s, the construction assumptions were primarily tectonic. I mean, I was, like, for me, the state of the art would be rolled tubes and things like that. But I was really thinking in terms of an array of construction elements, which would be, let's say, more conventional elements of construction arrayed in unconventional ways. But so I was really thinking about the construction. I mean, with the church, it started with how do we, you know, more or less animate the frame in a sequence to produce the right spatial effect, and then how do we clad that frame. And so now I'm thinking about a different set of materials, and so it's really still the same tools for me. I haven't really picked up a new tool set in a while. So, I mean, to the degree that we'll have variables in parametric modeling, it's really pretty predefined. It's not, I'm not really using it as a form finding tool so much, but as a rationalization tool. So in that sense, I'm out of step with all of you. I mean, I'm behind the times with all of you. But in terms of materials of construction and assembly, I'm thinking about a different way of constructing.
Well, I mean, this is actually interesting because a lot of people who use generative tools have a problem materializing.
Really?
Well, I mean, okay, for fabrication purposes, if you use it purely for fabrication in terms of using, let's say, panels or modular systems,
Yeah.
then in that case, not so much. But in cases where, like, let's say, evolutionary algorithms and so on that are kind of becoming more integrated, if they get too complex, then at some point in time, I would say so.
Yeah. Well, Mark should answer it, but it's my sense that the construction industry, most of its aspects are an industry. I mean, in the ground, though, the minute you're out of the ground, it's an industrial process where most of the people supplying components are used to supplying components to different buildings the same week. So they're tooled up. It's really just recently we got tooled up to take advantage of the industrial character of the steel industry and the glass industry. And so to a certain degree, I think, you know, Zaha and Patrick and Norman Foster, all kinds of people locally have just totally exploited the fact that, you know, hey, we actually are working with an industry here, not with craftspeople. But they're not pushing back the way other industries would, which is like, okay, you know, I'm real happy about these complex tools, but let's look at economies of construction and ergonomics and, you know.
I mean, one of the things that you mentioned, I guess it was at lunch today, about the flatware that you designed, right? And the idea that it couldn't become cost effective and something that could be sold on the mass market because of just the process, right? There were 5 steps that you mentioned that had to happen in order to make those pieces. So a lot of the construction world is based on that same philosophy, without a doubt. So ideas like these joints perhaps that move during an earthquake, I mean, you would be amazed at how long that process has taken just to seed the idea and get people interested, because the process will change. And it will be perhaps more costly, at least initially, to do things like this. But these are just scratching at the surface. I think that production side, somebody mentioned in a couple of cases, projects that perhaps you did, Greg, the zero waste idea, the idea of fabrication with zero waste, right? Really, really important concept in the built environment, if we can get there. So I think as these forms change, and there are opportunities to use external mechanisms like heat, for instance, to change the shape and use material that leads to low waste, I think is a really important concept.
Going back to, I mean, you were both talking about the same issue actually. For example, you said that computer gives consequences but not solutions, like it's a process of going back and forth. And you were kind of talking about like generating these multi-parameter systems, but that again you have to evaluate each time what the system does, and you know, how would you evaluate a system like that, because it's getting too complex. Do you think that, digitally speaking, we are still lacking how to understand the results that each time is given to us, like the consequences, the fact that we cannot, the fact that the digital tool cannot offer a solution yet? Do you think that that should be, let's say, the way to go, or should it be more intuitive, like upon the designer, or should it be even pushed further in a digital realm, let's say?
I can start. I really think that when we talk about these modeling techniques, we talked about parametric modeling, where we have perhaps several ideas that are layered on top of each other, and perhaps we can weight those functions. Mm-hmm. So for instance, in the example that I gave you on a tall building, there were 4 or 5 parameters that were considered. They can all be considered at one time, and you could weight, you could say that perhaps the light in the space is the most important thing for me on this particular site. Mm-hmm. Those functions can be defined without a doubt, and I think that they lead to a solution, yeah. But perhaps that solution will be modified because for other reasons that the ideas are probably not optimal for that particular case. But I think it's more informative in many ways than something that's just absolutely prescriptive. And I think what we're interested in very much is raising the awareness of design of cities, so that we're not just thinking about creating space in a way that is very harmful to the environment. There might be ways of using different materials or different placement of buildings on sites that overall reduce the effect of these ideas on the environment. So I do think that there's huge potential in these ideas in terms of weighing out different parameters when we look at these more complicated designs.
There's also a lot of low-hanging fruit out there. I mean, in the building industry, there's so much low-hanging fruit. Yeah. To try to do it all at once is tougher than just going after the easy ones. I mean, like formwork. Yeah. Just say, look, we're going to spend 30% of our material throwing it away for formwork. How do I approach it from a formwork standpoint, or how do I approach it from a, daylight standpoint, or something like that? I think in a certain way, the multivariable analysis is super powerful, but it's most powerful as you start to lock certain variables down and seeing the consequences on the other ones, then you leave variable. But to leave everything variable and try to focus in a design space, that's tougher. But I think our field, there's a lot of things you could attack real early on and make it a focus. Probably in everybody's analysis, it seems like, or in everybody's proposal, it seems like you could state what those kind of low-hanging fruit would be.
A question for Mark. You talked about volume quite a bit and perceiving buildings now through volume and not surface. And I'm just, I'm wondering, how do you see, do you see a shift in the process of design? I mean, or in methods of drawing, or approaching, building design, and how the drawing method changes, perhaps, even with tools?
Yeah, there's no doubt. I mean,
is there?
When for most projects, the sort of first step of attack for us and many other people that are in practice is setting up a rigid philosophy about how you're going to react to a form. So, I mean, in the simple sense, it's grid lines that get created to take that form and try to decipher it right down immediately into something that you can define. And it's done, and it's still very much in a plan and elevation type way. So the idea is to come up with a much more fluid way to define that structure. So if you think about forms three-dimensionally, it's very complicated because in our world, when those forms are occupied, it's not so easy to have structure passing through occupied space. However, it might be the most efficient way to resist load. So the art is to try to come up with a way that goes beyond just the outside surface, but internally, what can we do? And we do things like, we place reinforced concrete cores and we surround it by frames. I'm talking about the interface, interconnection. The idea of bamboo is a good one. Okay, the idea that you have essentially a hollow shape that's stiffened by diaphragms, and those diaphragms are placed along the height of the column to keep the walls from buckling, right? But they're not randomly placed. They're segmented in a way that are mathematically describable. So they're closer at the bottom, they open toward the mid-height, and then they close again at the top. And the answer is, the reason for it is because of the applied load. So in some ways, that's a three-dimensional response. If you think about it, you've got a shell, and you've got these internal elements that are passing through the space to help brace the walls to keep it from buckling. So I think there are ways for us to interpret this so that that three-dimensional form can be defined and can be usable. Because if for us, if we can't pull it across to something that someone can use and occupy and sell, for instance, then it becomes an idea that perhaps just a concept.
So when you say define, do you mean defining the structural qualities that then drive it, basically, or?
It's both. I mean, it's defining the structure, it's defining the resulting form, the architecture. It's an interactive, it's without a doubt, an interactive process. And it isn't, and the way I see it is not, it's taking those forms and it's being much freer about the response. So for instance, using a material like, and we're stuck in some ways, but using a material like concrete and using a fabric type forming system that perhaps can be used to create a much more fluid response is a way that I think could be used in structures that have complex forms and perhaps load flow that isn't straight lines, those type of grids. And I think that's where we're going too, because I think our forms are changing considerably. We have to be careful about willfulness, right? We have to I think come up with ideas that are responsive, that are efficient, but they're not willful. So in other words, pulling and creating something that we think is beautiful may not be the most efficient way to do it. And so there's this balance, right, between willful design and natural response.
Yeah, when you say volume, I think certain architects it may just apply. Oh yeah, sorry. For certain architects, it may apply spatial volume and not necessarily thinking structure.
Yeah.
So they can begin to pull and kind of, do as they wish.
But maybe the difference between engineering and design, I'm not sure, but let's say looking at I forget what she was calling them, the acoustic elements that were landmarks, the sound marks.
Oh, right, sound marks, yeah.
And using acoustical tools or geometric tools used acoustically
Right.
to optimize them. For me, that's an engineering task, the same way optimizing sun angle is. But if you can start to do 2 or even better 3 things with the 1 element instead of 3 things with 3 elements, for me anyway, that's where design kicks in. So how do you do sound marks in a city that also behave as infrastructure, or I don't know what it would be.
Right.
But I really believe that it really hit me with the problem of the chair. And I'll tell you, Rolf Feldbaum says all architectural theories are tested in chairs, and I think he's a little bit right when you look at all the architects that did chairs. But I remember there were a lot of parametric chairs which had like thousands of pieces of structure. And I remember thinking, like, let's try to solve the ergonomic seating thing with 3 layers of foam and 3D knitting, and try to do upholstery, comfort, structure, all with, you know, more or less one sandwich. And so for me, it was like a revelation. So now the question is really not how do you use a complex geometric tool to solve a problem more complexly, but how do you take 2 disparate things and put them together with the same solution. So, I mean, I think whatever it would be, structure of tower with circulation of tower with, you know, wind profile or solar profile or something like that, that's where designers are really good, is integrating these different systems. I mean, that's the stupid thing with that buoy, is everybody's sitting there trying to figure out how to get it out of the water. So why don't we just, the stupidest thing a critic does when they turn your model upside down and say it looks better, I just said, why don't we lay it down? That's only a designer would do that,
Yeah.
except some of your software. But anyway, I think solving multiple things with the same element is really what's most interesting about these tools, rather than making something which was not complex more complicated, which is what Branko was saying.
Take the buoy example. I mean, I think this is a good one. And for me, I think the greatest opportunity that exists right now is not just a definition of form, but it's how much how many lost opportunities we've had and perhaps will have if we're not careful. For instance, we take these massive structures and we encapsulate them. Okay? We create a form that protects, that controls internal air environment, temperature, humidity, and so forth. But how many of us are really looking at the potential for that surface in terms of generation of power? And these are advancements that are far beyond, I think, what current science is. But it's this layered approach. We talked about the idea of regeneration. I think it's very, very important that the next stage for us in terms of real development in some of these structures is about regeneration and coming up with ways to be self-efficient. The idea that, you know, we have these lifelines that come from the ground to feed these massive towers, and that's the source of power and water and so forth. My goodness, I mean, we have these opportunities to create areas within these structures that aren't completely in need of these sort of services that exist that are very inefficient and so forth. So anyway, these are things to think about. So it's a multi-layered kind of idea, I think, in terms of form and other functions.
I have a kind of a general question also. It deals with the theme of the whole symposium, you know, the idea of representation drawing. How do we communicate these dynamic systems that we're generating through documentation? What do you think of do you think that the way we document things right now, I mean, in paper form or let's say through movie simulations, do you think it is still lacking something in terms of, you know, really communicating this idea of changing over time? Because let's say as PhD students, when we have to publish, you know, a document, a book about these things, generally what people do is, you know, let's say you have a simulation, you have to capture some frozen moments and lay them next to each other. Or let's say you're dealing with a very complex space that doesn't really have a wall or a floor, but you have to make sections and plans. I mean, it's also a more general topic, let's say, but how would you think about this idea, how representation could be maybe more improved?
Those are big questions. I mean, one thing I'm doing is I'm advising the Canadian Centre of Architecture to build the first digital archive of architecture. And I consciously picked 4 projects from the 1990s. And so far, only one has any digital material left whatsoever. And they were all generated completely digitally. And some of them even algorithmically. And nobody can either find or open any of the data
Yeah.
from the 1990s. And so, seeing as you're, I mean, I know you're not, all 6 of you are a little older than your average student, but you're not that old. I'd be thinking about the longevity of the work you're doing archivally in a certain kind of way.
Yeah.
Like, how is it gonna not be outdated when Rhino gets bought by Autodesk and there's no more Grasshopper? So, I mean, for me, that's one of the questions I'd be asking myself
Yeah.
when I was saying, what am I gonna produce as a dissertation document? I'd be thinking, like, how would it go into a place like the CCA and be relevant in 20 years?
This is
So
this is a
that's
huge
true.
issue, okay? I mean, for those of us that, you know, are in this world of creating something that gets built and needs to operate and those sorts of things, and then 20 years or 30 years later, we need to find out about what we had done so that we can react to something, right? Whether it's the mechanical systems or the structure or whatever it is. It scares the daylights out of us. We don't know, I mean, we still don't know exactly, and Hodge said it very well. He said, well, why do you need, why can't it be interactive? Why can't we just, you know, remove the paper from the process? It's a really good point. I think we're getting closer, though. Every time I say that, you know, we go from, you know, cassette tapes to, I mean, anyway, it goes on and on. So I don't need to say it, but it's just in the world where you really do need to be back with it in some way, and it happens very frequently in ways that you don't expect. We still don't quite have anything but the drawing representation. It's amazing to say that, even with all the digital science that we use during design.
I also tell my students that the only thing that will remain from their work in 20 years is the thesis on the shelf. That's it. All the files
It's
are on the file.
incredible. It's
Yeah.
actually, it's an incredible issue.
But does the client necessarily care about process?
That's a good question.
I mean, I know we do, but
A lot
I'm
of
just,
cases, no.
yeah.
A lot of cases, no. There are some very informed clients that do care very much about that,
Really?
but it's not all clients, no. They care about the product, without a doubt.
Yeah.
The
Yeah.
product. Now, how you got there is maybe a different story.
Let's say hypothetically, you build a tower based on centerline geometry and dimension strings. Let's say somebody else comes along and builds a tower which they grow with a generative algorithm.
Yeah.
If you wanted to modify the one with the centerline structure with dimensions, you know where to go to modify it. If you grow it, don't you have to keep that algorithm alive or
Right.
something? I mean, in order to, I mean, what are you gonna hand the client for as-built documents? In case you wanna have a building which is dynamic and transformable.
Right.
So, yeah, I think somehow you have to figure out how to keep that stuff relevant, the same way you figured it out with drawings.
I guess you could hand in the client the inputs for maybe growing the algorithm, like the algorithm stays, but you have, like you were mentioning, you have certain inputs that change and certain inputs that don't change. So when you hand it in, you would dictate which inputs they can change, let's say, and then, so it's still designed by the architect, but also the client could have some
But
kind of
you have to give
interaction
them
in the.
instructions too.
Yeah, I think what Greg said about, for example, let's say there's a lot of process to get to that level. So you would lay it all out in, let's say, Rhino.
Yeah.
And then Autodesk comes and buys Rhino, and it was all in Grasshopper. So 10 years later, or whenever, if they do want to go back and, they're limited to kind of the software that it was created in almost.
But the
Because
process
otherwise,
language
they
is
have the
different.
process, but they would have to rewrite the whole process in some way, it seems like.
Well,
Well, what do you think? Do you think we can get there?
I would
mean, do you
say-
think there's a process to overcoming this? Because it would be great to hear what you think about it. Because, we're faced with these sort of practical matters, and I hate them. I mean, this is not, it gets in the way of development and ideas, really. But do you have thoughts about? because you guys are doing some really advanced things, that not everybody can sort of get their hands on, unless you create a device, right? Like Apple has done, for instance. Unless you create a device that is able to manage those in a very simple way, then I think we've got a long way to go. But I think that maybe that's the part of the clue. I don't know.
It's a bigger cultural issue. Actually, the libraries are dealing with the archival of websites, and much of the website content, think of all the flash animations and all the things that are dynamic with websites, are similarly dependent on plugins and software and operating systems. So it's a kind of, it's not just our problem, it's the kind of issue for the entire society, how to archive the web content as it exists today, and as it exists tomorrow, and so on. And just think of the colossal amount of data that would have to be somehow captured, and all the software that has to be captured with it, for some kind of future archival historian's work. So think of the PhD in history, I don't know, 50 years from now, where they have to look at the kind of, they want to see the website of Greg Lynn Forum as it existed on this particular day.
I mean, what's just as a funny anecdote, one of these 4 projects is Peter Eisenman's Frankfurt Biocentrum, which as far as I can tell is the first algorithmically generated project on Earth. And I'm sitting with Peter and I'm interviewing him on videotape, and I say, well, you remember I started asking, why did you decide to use a computer? That was the first question I asked him. He goes, we didn't use a computer on that project. And I said, look, here's the archive. There's 1,400 pen plots of different examples. He's like, oh, I forgot we used a computer on that project. I said, well, you do know it's the first algorithmically generated project in history, so you'll probably be famous for it, more famous than your early houses or something. And the same thing might happen to you guys. I mean, that was in that was in 87. So that was 25 years ago. But he'd already forgotten not only the process, but there was even a computer involved. So that's why I think thinking the long term is important. I mean, in 25 years.
John Fraser, who taught at the AA, he was here last term. And he mentioned that, I mean, we as architects have to actually redefine the tools, just completely, like, just build our own tools. I think in response to Mark's question, I think as long as we're using other tools, we're going to be limited to that. And what John was kind of proposing is this idea of writing from scratch, your own tools that allow you just to, and it completely changes the manner in which you design as well, to kind of do, perform the tasks that you're after. But until that point, I mean, I think the problem that we're facing is we're jumping from this program to that program, from this language to that language, trying to bring data in from this one to that one in order to create something, right? And I think we're still having the same problem. Okay, so I guess.
So you know, though, Ollie, everywhere else they complain that they're using all these stupid architects' tools. When you go to Hollywood and they're like, why don't we have our own tools? Why do we have to use all these stupid architects' tools? Like Avatar, the management of the digital jungle in Avatar was done with Revit. And if you talk to the 20 people that had to manage the jungle in Revit, they'll complain to you endlessly about why are all software tools designed by and for architects. Because I think sometimes when you look out, you actually don't get the whole picture as much as when you look in. But I would challenge you to find a tool that anybody uses in any digital field which was not designed for architecture. Like the naval architects that use Rhino Naval, I mean, they complain endlessly about it.
Yeah.
But I don't know, I think we got too many tools designed just for us.
So is that a problem?
No.
Okay. Well, no, because I mean, it almost poses a problem. I mean, because.
Well, no, it says I don't want you writing more tools. It's like enough already. The idea that we all have to write our own tools. It's just like It just seems
Yeah.
like we're following this trajectory, and eventually the future is every architect's gonna have to write their own software package for themselves, and actually that's starting to look like what it is.
Yeah.
Okay, we're going to ask all of our guests now to come up here and have an open discussion. We can open it up to the audience as well.
So if you have any questions from the audience, please, there will be a microphone going around, so you could.
This one needs to be close to the mic. Yeah. You can jump when you want to say stuff. It might. This one's not working, right? How about we have one rowing mic? Only one of us can speak.
Press this button to speak again.
I'm just curious if any of you guys have a question amongst yourselves. That would be my first thing. Okay.
I have a question.
From the others, or yeah.
So, I've been watching all these beautiful structures that you show, but they're always from Barcelona, and there's always a couple of. I've never seen these structures in anywhere except in these architecture show and tell. So I'm wondering at what point will I don't know, ordinary architects use this in buildings all around us? I mean, I keep seeing, McMansions and the same old standard things, and all these amazing design tools seem like they don't propagate into mainstream use. So at one point what will it take, let's say, to have all these ideas propagate to mainstream architecture? I'm asking that as an outsider.
When will it happen in robotics?
Well, I would say that in robotics it is happening already, but I haven't seen it yet happen. So what will it take? Is it tools? Is it are the ideas? Is it cost? Like, what are the barriers?
I'm just passing the mic.
I think it's complexity, without a doubt. And it's when we talk about the industry, I think that the time from concept to something that perhaps will be built is a short period of time, relatively. And we see it in the engineering world all the time, because, and the example that I'll give you is code versus performance-based design. Performance-based design, there's a huge amount of rigor that goes into that design philosophy, where you really understand how all of the components behave during certain loadings. Well, not everybody is going to do that, because number one, it could be time. Number two, it could be just lack of background in those tools. And number three, it might be that the particular idea that you're dealing with doesn't necessarily need it. A hand calculation, for instance, might be enough. So there's a whole world of practice out there that is not as sophisticated. But I think that there are movements in the direction, it's very slow, where I think more and more firms, individuals and firms are looking at it. So I do think it's several reasons why it hasn't completely taken hold.
I think also it's culture very much. I think you can see that already if you're traveling to different countries. Like basically being in the Netherlands, you have a very different design culture, which is very prevalent, very omnipresent in all scales and all cost sort of levels, not persistently, but much more sort of popular, let's say, than, let's say, the US. So I think it's an appreciation. Without appreciation, you can't push for, let's say, for progress. So I think many of the McMansion owners were proud to have the McMansion. It was a status symbol. It was an achievement, not a like where is the real innovative structure here. Innovation was, let's say, maximizing volume and assets and sort of measurable sort of house price sort of checklist. Right? How many bedrooms? How can I get more of a certain metric of success, let's say. So I think it really starts at education. So for instance, I don't think high school has much architectural curriculum in many countries. So I think if you introduce such appreciation, similar with engineering, if it starts much earlier, there's a sense for what is an achievement, what is a sort of desirable goal, or what is a challenge in it. I think it has to really work through that, and I think also that's relating to the archive question earlier. I mean, how did the libraries of the Middle Ages survive? How did the Gothic cathedrals survive? It wasn't an engineering solution. They would have fallen down within probably decades, but it's an appreciation and the continuous support and appreciation and investment of the community that wants them to persist. So the books only survive, not because paper is particularly good. If you put it out in the rain, it's going to be gone within probably weeks or days. So it's not that it's superior, it's just that the culture has been formed around it, how to keep it alive. Right? So I think the same thing has to happen with both design, but also with the digital artifacts. We have to figure out how to care for it, and also that the content is cared for because it means something to those who want to preserve it.
But I think also, Brett's not paying me, so I could say this here, but the field's really contracting. I mean, the jobs, it's not just that the construction industry is slow, it's architects have been becoming progressively less relevant for the last 50 or 100 years. And it's probably looking like we'll continue to become less relevant. What I think is optimistic, and I don't know, I'm not sure this is a fact. I read it in the LA Times on the way over here, but that half of all graduates of master's programs of architecture globally practice in architecture. The other half go other places. And the number of architects, you know, running design at BMW, running design at Nike, running design, you know, at Benetton, the skill set that gets cooked in architecture schools at various moments in history ends up becoming more important in other industries probably than it does in building trades. And so I think, you know, I bet you didn't hire an architect to do your house. I mean, architects don't do houses. I mean, I don't even know what percentage of it is. Got to be like 1/100th of 1% of all houses are done by an architect. So if you found a McMansion designed by an architect, I'd be surprised because they're like, it's like seeing a unicorn. But
industrial design.
yeah, I mean, your shoes were done by an architect. And pretty soon you'll actually go to Nike and you'll talk to a shoe architect who's going to measure your foot, specify the stuff. They're going to literally grow. I don't know if you knew, they're growing leather now at Nike instead of killing cows. So they'll literally grow your shoe for you, but they don't want to, I mean, they're not going to let you punch around on a website to pick it because nobody does that. They want you to go talk to a shoe architect, and the shoe architect's going to listen to you, write the spec, do the document, send it to the factory, and it'll get assembled. So our skill set, I think, that's getting cooked up here is super relevant culturally. I think building trade-wise, you put your finger on it, it's maybe less relevant.
I just want to add to that. At the university where I teach now, we had an associate dean come to us from business school, and he wanted us to teach design thinking to future MBAs. And I've learned from him that it's now very fashionable in business schools, that they're beginning to admire nonlinear thinking, that the way they see it in our discipline, and they would like to see more of that nonlinear thinking as a path to innovation in other domains. So, you know, I'm very optimistic about architects as thinkers, but architects as businesses, or I agree with you know, Greg, that there's a kind of sense of peril, and I think the kind of business equation of how architecture operates as a profession will require some rethinking in the future, because I don't think that the kind of present mode of operation is kind of sustainable in the long term. So, but there are some hopeful trajectories in that area as well. So, but I'm not going to dwell on that right now. It's a kind of
tricky topic.
I'm not going to add anything to this discussion, but I wanted to, going back to what you were discussing before, to change from architecture, because you were doing the design of the boat, and you were saying that it takes 1 week, 9 days to have the results from the fluid dynamic stuff. So since nowadays it's so easy to print and to get a rapid prototype of such a thing, wouldn't it have been kind of a bit quicker maybe to print it and to test it in a real kind of small pool, scale pool with, I don't know?
No, that's the most luxurious thing you could do. There's one place that can test a multi-hulls, $10,000 an hour to push the water.
Whoa, okay.
No, the computer's the most, even though it's 9 days, it's the cheapest, most efficient solution.
Okay.
Wouldn't it be better to build a 1/10 scale model of a theater and fill it with nitrogen and record sound in it?
Actually, we're doing this.
I know you are, but how much does that cost compared to software?
It costs a lot, but with rapid prototyping, it costs a lot less.
This is true.
I think it's a developing field.
Yeah.
It's something that I'm looking at now, and it's something that we are doing it anyway with projects like big opera houses that they cost, I don't know how many million euros or whatever dollars. So I think it's something that has been not used that much in the past, I don't know, 10 years.
It's not used that much because we kind of started to use a lot of software because it was kind of cheaper. But now with rapid prototyping, we can go back to that previous thing, and now we can print the surface with all the double curvature we want and make it as it is, you know, because before we were just kind of trying to cut some timbers, sticking it together, so it wasn't even close to reality. So now I think, yes, it's for acoustic it's good.
The coolest thing I heard is I was at the Oracle. Well, actually, I shouldn't be saying certain things I shouldn't be saying.
I can do the beep sound if you want when you say the word.
No. The way they do it now is they put fiber optic load sensors laminated into the boats, and the structural engineer, instead of sitting in front of his machine, is out there with a pad racing and testing and looking at the loads. And like a fighter plane, they now just sail by the loads. So they don't go for a speed, they go for right to the edge of where you're going to break it. And what's funny is they used to have a red light, green light set of sensors on the boat, and then the racers started only sailing to the red lights because they're like, well, we're not going fast enough because that light's green, we're still safe, we got to make it red. They kept breaking the boat. So now the structural engineer is there doing the engineering on a pad that's using the sensors, and every night they go back and they laminate extra cloth or chop things with a Sawzall. And in fact, the idea of simulating and then building is so blurred at this point that they don't even tank test anymore. They just build the boat, put in the sensors, sail it, and look at all the loads with a very high-end computer on board with them, and then are just cannibalizing the boat for a year as they go. They wouldn't even bother building a model. It's the full-scale thing, and the engineering is all happening all at once. So, I mean, maybe that's an exciting place where the building industry could go, is instead of simulating and designing, you're actually adapting and modifying and, you know, refining the design after the moment of construction.
But in a way, the sort of script they were developing for building this kind of a drawing, and aren't this script and this software something that maybe we need to look at a building that is not built in one go, but maybe something that keeps on growing, and so the software that generates it is something that keeps on changing with time and with, I don't know, the price of oil or whatever. And maybe there is space in this way for a new professional figure that is kind of taking care of the growth of the building, like a gardener. I don't know, but something like that.
Does SOM usually get the jobs to do the tenant improvements on their building?
Sometimes. Sometimes we do, yeah. Not always, but we may be involved with the structure at some point, you know, the architecture. It depends. Yeah, it depends.
Because it would make sense for large firms to have that kind of business model.
Could also be an incentive for. Could also be an incentive for actually keeping the data around, right? Which I meant before with the caring for it, right? If you actually own the data, that makes you more capable to run the place, so to say, and also be sure about it. That may be an incentive rather than thinking of it as an archival thing. It's a business proposition because it takes so long to actually catch up with the initial investment through the operation. That may be also a way to stay involved, right, and also leverage that knowledge for improvements or additions or changes, and maybe also a way to argue for the persistence of the investment as opposed to tearing it down and building it anew, which I guess somehow today is still possible in many cases, although it doesn't make any sense energetically or resource-wise. I don't understand the mechanics, but I can imagine that it may improve if you know more about it, how you, with small or incremental changes, you could improve it, as opposed to sort of blank slate.
Okay, does anyone have any questions out there?
We're not leaving until you have a question.
Is one enough? Or
Okay, no questions? Yes, okay.
I have a question regarding the rapid prototyping. So you mentioned that you use that for acoustic testings in small-scale models. How do you think that rapid prototyping, also regarding the article in the Economist, will be used in larger scale in architecture? Because, for example, it's used already for, like in the car industry, to produce large-scale prints. Like, how do you feel that this would be maybe go into architecture?
I don't know. I think I hope that rapid prototyping will get better and cheaper. So in a way that we could use it to produce cheaply and without wasting material, even parts of buildings. So you could think to, in a way, you could even think to have even the interior of a concert hall like a puzzle of pieces, and something can happen. You reprint some pieces, and you kind of plug it inside. And because, I don't know, maybe in 10 years' time, that won't be anymore a concert hall, it will be a theater. So maybe you will need to do something else to it. So you can kind of plug pieces inside and cheaply kind of modify the architecture. So that's evolving and being always updated with their needs.
So in the lab, we have been using a Fab at Home printer to print in clay and embed elastomers inside and conductive materials for wires and so forth. So we're printing these bricks that have all kinds of components already printed in them during the print. And then you can take these bricks, which are each one is different, and assemble them into a wall or structure like that. So you have basically two approaches to using rapid prototyping. One is large-scale, very large-scale printers that can print, you know, rooms and rooms scale, still not building scale, or printing components and assemble them, which is much more parallelizable because you could have, you know, 50 printers, each printing a piece. And if you want to build a structure twice as fast, you get 100 printers. So that's the other approach. But I don't know, but I don't think it's cost effective though. It sounds to me like it's you know, it's very expensive to do it that way, but it's very versatile.
I think also one trend that is interesting is the shift from where you have the machine that's bigger than the part always, right, which is the easy criticism or the easy way to shoot it down, right? Because then you always need to build a machine bigger than the building, which is probably worse than the scaffolding problem today, right? Because it has to be higher precision on the thing you're building at the scale, and et cetera, and more distortion resistance. So I think the other thing is then to look at actually which is already happening, building machinery that is enabled, let's say, through very precise GPS tracking. So you have an earth mover that moves around in space and actually does very precise, but constantly having feedback from what it does with respect to what it should be doing. So to do much more similar to robotics, which also went through that shift, right, of having top-down cameras looking at rooms being as big much bigger than the robots inside, right, and always having to know about the entire world. To embodied intelligence, where you have robots, you throw them in the room and they figure out what they're doing and make a dynamic mapping of the changes to the environment they're affecting it. So that construction could turn into something else similar, very noisy swarm of embodied constructors, so to say, which try to achieve something but don't fail if it isn't perfect, but just go back and improve on it. Similar to maybe hanging 6 degrees of freedom arms on tower cranes. So you use the 6 degrees not to sort of be precise, but to compensate for the noise in the system. And then do maybe 2 more or 3 more degrees just to do the placement correctly. Right? So there's lots of issues with that. I'm not speaking as in the authority, right? But I think you have to really think differently at those scales, right? And I think robotics went through that already, right? At small scale. So I think it's going to be interesting to see these sort of noisy, localized agents, so to say, that build and then sort of do things with much bigger volumes of material and more sort of fault tolerance, I guess.
Well, also the two spectrums for robotics, the kind of Cirque du Soleil, Vegas, roboticized building elements, which are just spectacular, like the second guy's proposal for the canopy. I mean, in a certain way to say, well, it's a functional thing, misses a little bit the fact that already there's spectacular robots in the cities. And then the Kiva robots, which are kind of reorganizing the whole way space is colonnaded. And I mean, those two extremes, the middle is going to be real interesting. I mean, I do think very soon we'll have a robotic, slightly roboticized hotel room, let's say, that's an equivalent of a Murphy bed. So during the day, your 600 square foot room is like an office, and then you go out and come back and suddenly it's a bedroom. Just because, not even necessarily efficiency, but it just makes sense that you would start to animate environments at that scale, somewhere between the kind of furniture scale of the Kivas and the spectacular scale of Vegas. But I think the action is in how to move buildings, not how to make them. Make them, that's like 2000. Architecture schools. It was all about how to fabricate. It's, you could go to the most remote school on earth and they're going to tell you about their 3-axis mill, or they want to get a 5-axis one. Everybody's figuring out how to make stuff. I think the action is moving into how to move stuff.
You mean reconfigure the building?
Just how to move stuff. I mean, Axel, I think, is totally right. You don't think about how to use a 3D printer. You think about how to use your Caterpillar earth mover as a 3D printer. So I just think moving big scale elements is where the action is going. It's not so much how do we laser cut stuff. I mean, it's done. It's done, and other people are working on that problem. Big minds should be working on the next problem, because they'll tell you the whole field is educating people to laser cut and 3D print. So.
But moving things doesn't really need to involve robots. I gave a talk here in January on architecture of change, and the change in architecture is a huge topic. Like, what should move, why it should move, where it should move. And then I showed 2 projects, one by Shigeru Ban that had rooms on wheels. It was called Naked House. It's just a big shed with lots of rooms and wheels, and these 2 bodies one body could reconfigure the space. And not too far from here, there's a sliding house where actually the entire enclosure of the house sits on 2 rails, and it's powered, by 2 motors with 2 car batteries. It's easy. Flip the switch on, it moves. You flip the switch off, it stops. So it doesn't have to be complicated. It doesn't have to be complex. It can involve some really simple strategies but the bigger question is why things, again, should move.
Why shouldn't they?
Well, let me just give you an example.
If it's
Say,
so easy.
say,
It's
say,
easy as
say.
you say.
No. I'm not saying it's as easy. But imagine. No, but let me add.
You did. You said it's simple, easy.
It
doesn't
could
need
be.
to
No.
take robots.
I said it could be simple and easy.
It's just around the corner.
Yeah, but imagine there is another set of issues. If things started to move, say the ceiling started to come down in this room, how would you feel about it?
I wouldn't have a problem with that.
Well, it can squash you. It can squash you because you would trust the technology to work. So it will.
Same as I trust it's not going to fall on me now.
Yeah, but I had some questions about that, the things that move, and our psychological reaction to things that move, and that change shape. I think it's a huge topic that deserves some digging. Instead of simply saying, things should move. I would say, why should they move? What's wrong with things that are static? I'm not saying they should be static, but I would like to see these questions answered.
If we're in the business of educating people for the future,
Yeah.
I think there's definitely, for a small subset, like at the AA, there's room to educate people in moving things
Look,
rather than making things.
No, but Peter Cook had the concept, and the Archigram had a concept of walking city a long time ago in the 60s. It's a kind of wonderful idea.
But they were never serious.
Ah.
No, I'm not being provocative, I'm being practical. No, I could get everybody in the room employed if they knew some basics of large-scale robotic construction instantly. Because the Cirque du Soleil doesn't have that skill set, and they're out of Chinese contortionists and acrobats, and so they're building robotic buildings to entertain people. And they're desperate to have architects that understand large-scale movement. Desperate. So I'm just saying it's a growth industry. It's not the future. It's not for everybody. You won't live in a moving house. But you won't live in our house designed by an architect either.
Regarding this topic and moving stuff, I don't know, we might be pioneering acoustics. No, meaning that when we design a concert hall, let's take the Sage Gateshead in the Foster project. That concert hall can be used for whatever type of concert, from orchestral music to speech and lecture and to amplified music. And there is this 5 massive pieces of ceiling that they are going up and down with the most silent mechanism. Or the same thing works in stages for opera houses now. They have kind of 4 stages moving scenery around while there is someone playing on stage, and you cannot hear a thing. It's just amazing engineering. And that stuff is available. But as you were saying before, now in the climate we have at the moment, when we design a new hall, and usually the clients ask us to have a hall where he can do pretty much everything, the budget is never enough to have movable pieces inside. So we need to have some compromises. So at the end, we kind of have some curtains coming in. But the curtains coming in is something, that moves, but it's not a piece of ceiling that changed the architecture. So we do find that it's still quite expensive for clients to justify the movable piece inside a place. But it's just our experience.
I think maybe it's also a dynamic of the spectacle. I'm fascinated by the iPhone and the handheld phones, how they put pressure on so many other artifacts disappearing. Like basically now you go to some, medieval house, you bring your iPhone and a charger or so, and then that's it, right? You don't put a stereo system, you don't put a DV, or all the other things that were technology maybe even just 10 years ago. Right? So, and it's also an attention sink. Basically, you have your constant satisfaction of the short-term sort of stimulus you have with you. Most people walk around like this; they don't necessarily look up, right? So, which then leads to, I guess, spectacle, points of spectacle. We have to really make something that's so outstanding and so different that people would actually pay attention. So I feel it's almost like as if it's the extremes, right? So the general environment actually gets does have to do less and less of the distraction because people are addicted to the sort of short span, sort of personalized, sort of everywhere. Whereas then to really get attention, you need to do something that may then justify the very sort of elaborate construction. So I'm wondering whether that's with the sort of omnipresent ubiquitous computing, whether it actually has led to a shrinking of computing into very few devices at very high sophistication. But at the same point, actually, most spaces have kind of returned or remain in this sort of robust enclosure sort of state and don't require anymore that much maybe of technology as it was anticipated maybe even just 10 years ago.
So we're going to wrap this up. I'd like to thank our guests, all of them, and this really great discussion. People are just hanging around to listen to it. They're kind of timid about the questions, but we can't force them. So I'd like to thank you guys for coming and hanging out with us and, you know, flying across Pacifics and other whatever.